Mutual information. These notes are adapted from Kenneth W. Church and Patrick Hanks' Word Association Norms, Mutual Information and Lexicography, which first appeared in the journal Computational Linguistics. Mutual information compares the probability of observing word X and word Y together, which is called the joint probability, Pxy, with the probabilities of observing X and Y independently, Px and Py. The formula for mutual information is Ixy, which is the code for mutual information, is log to the base 2 of the ratio Pxy, the probability of observing two words together in the same window, over the product of Px and Py, which are the probabilities of observing the two words independently. If there is a genuine association between X and Y, then the joint probability Pxy will be much greater than chance Pxpy, and thus Ixy, the mutual information between X and Y, will be well above 0. If there is no interesting relationship between X and Y, then Pxy will be about the same as the product of Px and Py, and mutual information will be about 0. Finally, if X and Y are in complementary distribution, then Pxy will be much less than the product of Px and Py, making Ixy much less than 0. The word probabilities Px and Py are estimated by counting the number of observations of word X and word Y in a corpus, which are Fx, which stands for the frequency of X, and Fy, and normalizing or dividing by n the size of the corpus. Joint probabilities Pxy are estimated by counting the number of times that word X and word Y both occur in a window of W words. So we call this F_W XY and normalizing by n. The window size is typically set at 5 words. Here we have an example. We want to see if there is mutual information between the two words doctor and nurse. In the Associated Press corpus, the word doctor occurs 1,105 times, the word nurse occurs 241 times, and the two words occur together in the same window 36 times. There are 15 million words in the corpus overall. So the probability of doctor is the frequency of doctor, 1,105, divided by the size of the corpus, 15 million words. And this gives us an answer of 7.367 times 10 to the minus 5. The probability of encountering the word nurse in the corpus is the frequency of occurrence, 241, divided again by the size of the corpus to give us a value of 1.607 times 10 to the minus 5. Finally, the probability of doctor and nurse co-occurring in the same window is 36, which is the number of times they do co-occur, divided by the size of the corpus to give a value of 2.4 times 10 to the minus 6. So the mutual information between doctor and nurse is the logarithm to the base 2 of the ratio. First of all, on the top, we've got the probability of doctor and nurse co-occurring, and then on the bottom, we've got the product of the probability of doctor and the probability of nurse. So that gives a value of log to the base 2 of 2027.2, which works out at 10.66.